All right, let's jump right in. For decades, one of the biggest puzzles in all of science has been this thing we call dark energy. But what if it isn't a force at all? What if it's just a mistake? Today, we're going to unpack a pretty fascinating alternative theory.
And this is the fundamental question, isn't it? The source material we're looking at today throws down a really bold challenge to one of the biggest ideas in modern physics. It's asking us to stop and reconsider pretty much everything we thought we knew about the expansion of our universe.
So first things first. To really understand the challenge, we have to understand the reigning champ. Why do most physicists even think dark energy is real? Let's quickly set the stage. To put it simply, astronomers looked out into space and saw that the universe isn't just expanding, it's actually speeding up. And dark energy is basically the placeholder name for whatever is hitting the gas pedal. It's the mysterious something that's pushing everything apart, faster and faster.
Now this is where it gets spicy. The source basically argues that dark energy is just a patch, a sort of scientific fudge factor they invented to make the existing models work. It claims this is a huge red flag that maybe something much more fundamental is wrong with how we see things.
Okay, so if dark energy is just a patch, then what's the alternative? This brings us to the core of this explainer, how the changing space theory offers a completely different way of looking at the cosmos. And there you have it. That is the central claim, plain and simple. This theory doesn't want to just tweak our ideas about dark energy, it wants to completely wipe it off the board. So, how in the world does it propose to do that?
And this is the critical point. The theory isn't arguing with the data, the actual measurements that astronomers have collected. It agrees with the numbers. What it's questioning is our interpretation of those numbers. The problem isn't out there in the stars, it's right here, in our assumptions.
Well, this is the million-dollar question, right? If the accelerated expansion we think we're seeing isn't being driven by some mysterious energy, then what is causing the signals that made us think that in the first place?
The answer, according to this theory, is all about a phenomenon called redshift. This is the absolute bedrock observation that everything else is built on. And the changing spaces theory suggests that maybe, just maybe, we've been looking at it way too simply. And this slide just lays out the divide perfectly. In standard cosmology, redshift is kind of like the siren of an ambulance. As the ambulance drives away from you, the pitch of the siren gets lower. We see light from distant galaxies shifting to the red or lower end of the spectrum, so we conclude they're moving away. But the changing space theory says, hold on a second, what if other things could be making that siren change its pitch?
Not just one thing. This theory suggests there are four distinct factors that could be playing a role in the redshift we measure. And if that's true, it would completely upend our calculations about the universe's expansion.
Okay, let's try to unpack these, because this is the real heart of the theory. Number 2 on the list, the movement of galaxies. That's our ambulance driving away. We know that one, but then it adds 3 pretty radical new ideas. Number 1, this fermion carrier ball is a complex idea, but it basically suggests the fundamental particles carrying light might subtly change or, I guess, age over their billions of years of travel, and we're just mistaking that aging for movement. Number 2 challenges Einstein himself, suggesting the speed of light might not have been constant over cosmic history. And number 4 suggests that our very methods for measuring distance are flawed, that space itself might have properties that stretch our measurements in ways we don't account for. I mean, each one of these ideas is a bombshell.
And for anyone who's curious, the source does note that these ideas are laid out in detail in a book called New Perspective.
So, if we take those 4 potential causes for redshift into account, where does that leave us? Let's bring this all together and look at the final conclusion from this new perspective.
And here's the big payoff. If any of those other 3 factors are messing with the light we see, then we can no longer just assume that a bigger redshift means a faster speed. The data we thought was acceleration might just be a mix of these other effects. And if there's no acceleration, well, then there's no need for a force to cause it. Goodbye, dark energy.
This is the theory's final judgment. It argues that we basically jumped the gun. We invented a mysterious energy that makes up 70% of the entire universe before we even fully understood the measurements we were looking at. It's a call to go back to the drawing board.
And that's really what this leaves us with, right? Whether this specific theory turns out to be right or wrong, it's a powerful reminder that science is always a work in progress. Sometimes an answer is just a doorway to a much deeper and way more interesting question. Makes you wonder, what else are we sure about today that might get completely rewritten tomorrow?